So, last class we have covered one example. Foundation is resting on brownish grey silty sand, it is completely a silty sand, and the properties has been given, and from the value of this your gamma, Cu, Cc by 1 plus E0, all the values has been given to calculate your immediate settlement as well as consolidation settlement. Water table is at located 1 meter below the ground surface. So, immediate settlement comes out to be 4.8 mm and consolidation settlement comes out to be after correction 62 mm. Total settlement is your 66.8 mm. Now, next is your by means of stress path, how to calculate your settlement. Stress path, it's indicate how a soil element is going to deform against your change in applied stress, then it is what rate it is going to deform, then what relation to one another. It has been given by Som 1968. So, generally widely it has been used as a based on your oedometer test. Now, take a graph here. This is your sigma V prime, this is your sigma H prime, this line is your isotropic line, and this is your K0 line. This point is your A, this is your B, this is your D, then this is your F, C, E. So, there are the 4 methods actually Som has studied by means of stress path method. How is your immediate settlement and consolidation settlement profile because of change in applied stress, and how the settlement variation, what is the strain, what is the rate, what rate, and what relation with one another. If I go to the method 1, this is your stress path, this is a 1, 2, 3, there is 4 method. First one is your AF, second one is your AB and AF, third one is your AB and EF, fourth one is your AB and BD, So, method 1 it has been given by Skempton and MacDonald 1955. Skempton and MacDonald 1955. In this case, if you look at method 1, this is your AF. What does it mean? If it is AF, what does it mean? That means pore water pressure, excess pore water pressure, excess pore water pressure, excess pore water pressure is equal to increase in vertical stress, increase in vertical stress. That means it should be linearly. That means whatever you will apply vertical stress, change in vertical stress approximately same as change in your excess pore water pressure. So, this is your method 1. Then in this case this is your stress path AF, this is your AF. Then method 2, undrained loading, particularly this is undrained loading. So, first one is your method 2 AB, it lies immediate settlement. Immediate settlement. So, excess pore water pressure, which is a function of stress, is equal to vertical stress. If you look at here consolidation settlement, they have said AB and AF. AF is your consolidation settlement. I will discuss slightly. So, if you look at here, how come a soil will go from A to B as immediate settlement, then there is no continuity, then from A to F there is a consolidation settlement. So, there is inconsistency, particularly method 2. Now, come to method 3. Method 3 is immediate settlement is a function of stress path AB. Again immediate is your AB, while consolidation settlement occurs along a stress path EF. Consolidation occurs in a stress path EF. So, if you look at here, so only total strain, only a part of total strain, a part of total strain along the path AF depends on the magnitude of excess pore water pressure, magnitude of excess pore water pressure. So, method 4, is your field conditions. There is a continuity, field conditions. So, if you look at method 1, method 2, method 3, method 4, all are your one dimensional consolidations. In method 1, very simple way assumptions, rate of increase in stress which is equal to your increase in excess pore water pressure. Suppose you applied 10 kilonewton per meter square, then 20 kilonewton per meter square, it is a kind of linear. So, with that proportion excess pore water pressure will increase. So, it is a assumption of your one dimensional consolidations. Method 2, AB is your immediate settlement and F is your consolidation settlement. There is no link between your immediate settlement and consolidation settlement. Means if you physically interpret in your stress path, AB is your immediate settlement, then F is your consolidation settlement. Method 3, immediate settlement is your AB, which is obvious, then consolidation settlement is your EF. Then what will happen between B and E? That means a part of your total strain along the path AF depends on the magnitude of excess pore water pressure. In that, a portion of your strain depends upon your magnitude of your excess pore water pressure. Method 4, it is actually reflecting your field conditions. What is method 4? First it go to the AB, increase in stress, immediate settlement, then it will go to your BD, consolidation settlement or primary consolidation, then DF, it is your secondary consolidation, it is following. There is a link, it will follow your immediate consolidation secondary, immediate primary consolidation, immediate A to B, B to D, primary consolidation, D to F is your secondary consolidations. This is what your stress path followed. So, if you look at here, effect of horizontal stress is completely ignored. In cases, if what I am discussing here, that means effect of horizontal stress is completely ignored. Means if you look at here, all depends upon your vertical stress, increase in stress. However, effect of your horizontal stress is completely ignored in your stress path. Now come to your settlement calculations. So, Som et al. 1975 they have given your settlement analysis by stress path method, immediate settlement, or elastic. In this case, assumption is your, it is homogeneous, isotropic, then elastic medium. So, in practice what happened? In practice, E soil, it varies with depth. What does it mean? If I say E of soil varies with depth, that means it is your non-homogeneity. So, immediate settlement rho I, which is equal to integration of 0 to z delta sigma V minus delta sigma H divided by E into Z. Delta sigma V and delta sigma H, or small h is nothing but vertical and horizontal stress. At depth, at any depth, Z means at any depth, it is your vertical and horizontal stress at any depth. Similarly, if you come back to consolidation settlement, consolidation settlement. In consolidation settlement, if I calculate rho consolidation is equal to mu 0 to z mv1 delta sigma z dz, mu is your in this case pore pressure correction factor, pore pressure correction factor. MV is your coefficient of volume compressibility from standard consolidation test. Coefficient of volume compressibility. So, for stress path method, consolidation prime, it is a stress path which is equal to 0 to z lambda mv z delta v and dz, sorry mv3, it is not mvz, it is your mv3. mv3 is your volume compressibility for 3-dimensional stress. mv1 is your volume compressibility for 1-dimensional, that means vertical 1-dimensional strain. This is your volume compressibility for 3D strain. 3D strain, lambda is your ratio of vertical strain to volumetric strain. Ratio of vertical strain to volumetric strain. So, delta U is your increase in pore pressure under undrained loading. You can write it delta U is equal to increase in pore pressure under undrained loading. So, if I draw a graph here in this case, so it will be coming out to be, it has been given in graphical form, this is your 0 to 1 and this is your k prime which is equal to delta sigma 3 prime by delta sigma 1 prime, and this is your lambda, it is varying 0 to 4.0. So, this one is your dark line, this is your observed, dotted line, this is your theoretical. Now, what will happen? K prime from there, if you look at here, from here there is a k prime delta sigma 3 prime by delta sigma 1 prime. So, k prime which is equal to 1 minus 2 mu divided by 1 plus eta 3a minus 1. So, where eta is your z by a into 1 plus z by a z square by a square to the power minus 1 by 2. This is your Poisson's ratio. A is your Skempton pore pressure parameter. So, this is what you can find it out from once you know the Poisson's ratio, once you know the eta, it is depth by your a, small a, z by is your total a is your distance, how far is your distance, it is there from there. So, once you get the a, then from there 1 plus z by a square minus 1 by 2, a is your pore water pressure parameters. So, most of the soils, if you look at here, most of the soils Poisson's ratio varies between 0.1 to 0.3, A is varying between 0 and 1, and from there K prime is coming about to be 0.6 to 0.9, and lambda is coming to be 0.5 to 0.8. For practical purposes, what happened? For practical purposes, MV3 is equal to MV1. MV3 is your MV3 is equal to MV1 for practical purposes. MV3 is what? Coefficient of volume compressibility MV3 for 3 dimensional strain. MV1 is your volume compressibility for 1 dimensional strain, that is your vertical directions consolidation theory. Now, this is about your stress path. If you go back to that example, earlier example, we can solve it by means of stress path method, we can solve it, then we can find it out what is the immediate settlement, what is your consolidation settlement. Same example, previous example, this is your case, here it is your water table, here is your footing is lying, here it is coming out to be 400 kilonewton, here it is 0, here it is minus 1 meter, here it is minus 5 meter, and this is your 2 meter, it is your 2 times B, which is equal to 4 meter. So, then beyond 5 meter N is equal to 20, it is your medium sand. Grey silty sand, gamma is equal to 18 kilonewton per meter cube, Cu is equal to 50 kilonewton per meter square, Cc by 1 plus E0, which is equal to 0.06. Now, if I start with this, now from the, by means of stress path method, if you look at here, rho C is your rho C prime is equal to lambda times, if I put it, volume compressibility in 3D strain for practical purposes is equal to volume compressibility for 1D strain. Then I can put it in such a way that, so it will be rho c prime which is equal to lambda times into rho c. So, if I go to here, it is your rho c prime is equal to lambda times rho c. So, k prime which is equal to k prime, you can find it out from here, equation 1, here it is your equation 1. So, you assume for this case Poisson's ratio is 0.3, A is equal to pore water pressure parameter is 0.7. So, from there k prime is comes out to be 0.84, and from there, because once k prime you are getting, it is your 0.84 you put it, and from there you can find it out lambda is equal to 0.6, and from there rho c prime is equal to 0.6 into 43.4. 43.4, if you look at here, here it is your consolidation settlement comes out to be your 43.4 mm, which is equal to your 26 mm, and total settlement, total final settlement is your immediate settlement plus consolidation settlement by means of stress pass method. So, immediate settlement for this case is comes out to be, this is the same problem, immediate settlement is your 4.8 mm. So, this is your 4.8 mm plus consolidation settlement based on your stress path, this is your 26 mm, and which comes out to be 30.8 mm. If you come back here, total settlement is coming here as per the earlier theories, immediate and consolidation settlement 66.8 mm, more you are getting. By means of stress path method, total settlement is coming 30.8 mm, almost it is more than 100%, double 30.8 mm, here it is your 66 mm. So, this is what is your calculations of your settlement calculations. I will stop it. So, next class I am going to start in situ stresses and stresses due to foundation loading. Once it will be completed, then I will solve more problems, then afterwards I will straight away go for your foundation designs. Start with your shallow foundations, then followed by different type of shallow foundations as well as raft, mat foundation, complete design. Thank you.